So absolute value inequalities. Remember, we treat an inequality just like an equal sign, except when you multiply or divide with a negative, flip the sign. So that means we're just going to approach it like normal. So if we have a problem like 3x plus 6 is less than 12, remember with absolute values, I need to write the two equations without the absolute value bars. So that's going to be 3x plus 6 is less than 12, just the way it is. And then the second one will be 3x plus 6 is greater than, I'm flipping the sign because I'm multiplying by -1 to make this a -12. And we did that in the previous lecture with the absolute value equations. So when you multiply this by -1, you have to flip the sign. Now we're going to solve each of them individually. So we subtract the 6. 3x is less than 6. Divide by 3. X is less than 2. Just like we did with inequalities before. Now -6, -6. So the only difference with absolute value inequalities is that you're going to have to write the two equations. And then we divide by 3, and we get x is greater than -6. And then we go and put them on the same number line. I like to have my students put 0, 2, and all these critical places on the number line. Don't worry about making all the dashes. So x is less than 2. Not equal to. So we're going to put an open circle there. And I know it's going to go this direction in the less than direction, so I'm going to put a little arrow there for now. And then it's greater than -6. So again, another open circle at -6. And it's going to be greater. So what happens is they're facing one another, so we fill in between. So this is one of those where x can be greater than -6, anything greater than -6 or less than 2. A lot of times we write it as a compound inequality like this, where you have the -6, x, and less than 2. So you're saying x is between -6 and 2. So let's move to another problem. If we go to, now before we write the two equations, remember we have to isolate the absolute value bars. So here we have this, and we have a 4 hanging out with it, not isolated. So it's 4 times everything. So to isolate it, we're going to divide both sides by 4. What happens is 4 divided by 4 is 1. So 1 times, I don't need to write. So we have absolute value bars of -2x greater than or equal to 8 divided by 4, which is 2. Now that it's isolated, now we can write our two equations. Remember, one with the positive, -2x is greater than or equal to 2. And one with the negative, -2x is less than or equal to -2. Because I'm multiplying by a -1 to get this, I need to flip my sign. Now we solve again. Okay, divide this one by -2, divide this one by -2. X is less than or equal to oh, I made a mistake. What was I supposed to do? I was dividing by a negative. So what should I do? Flip the sign right there. Don't make that mistake and just get going, right? Easy to do. You get into what you're doing and you just kind of like, So if you divide with a negative, flip the sign. Same thing here, dividing with a negative. So what are we going to do? Maybe flip the sign before you get going. That way you won't forget. And then you have x, and a negative divided by a negative is a positive. So there's the +1. Now we go to our number line. We have the 0, 1. Now it can equal -1. Last time it could not equal it, so we used the open circles. This time it can. So I need to say that yes, it equals -1 also. So I'm going to close in the circle saying that it's a solution, and anything greater than 1 is also a solution. Then at -1, right here, it's going to be another closed circle because it can include -1, and I'm going to have it be less than, so I'm going to go this direction. So this is one of those situations that's an or. So unlike the one above where we were able to write it as 1, you have to leave them as two separate things. X is less than or equal to -1, or x is